Hello and welcome everyone. My name is Kelly here with Esri and I'd like to welcome you to our webinar today. So today we're going to be discussing automated bathymetry for nautical charting. And with that, I'll go ahead and turn it over to our presenter today, Craig Green.
Thanks, Kelly. As Kelly said, my name is Craig Green and I work in product management on the ArcGIS Maritime development team. And I'll be presenting a couple of topics today. I'll spend most of my time talking about how you can use ArcGIS Pro to create bathymetric ENCs directly from survey data. And when I say create bathymetric ENCs, I really mean we're going to be creating depth areas, depth contours, and doing a sounding selection. But this can also be used in any type of electronic chart format. So it could be used, we're going to do bathymetric ENCs today in the demo, but this could be used in the tools that I'll show you can be used to create these same features for, S57 ENC, inland ENC, bathymetric inland ENCs, and also for S-101 as well. So this can also, these tools can write to S-101 data sets. And then the second part of the presentation, I'll show you how you can take that S57, because we're doing S57 in this case, how you can take that bathymetric ENC and publish it as a service and leverage that in the web or in desktop or in mobile applications as well. So before I get started showing you the tools, I wanted to take a minute to talk about the types of tools we'll be using. All of the tools I'll use in today's presentation are geoprocessing tools. And geoprocessing tools are a special type of tool. They typically perform one very specific function, like create a record or copy a feature or cut a feature. But there are hundreds and hundreds of these tools, and they can be strung together so that you can automate workflows. And there's a couple of ways in which they can be strung together. One is in a very simple to use user interface called Model Builder, where it gives you sort of a canvas, and you can drag and drop these geoprocessing tools into that canvas, and you can connect them. So sometimes tools have a common parameter in them, and you'll see that today, like they may all share the same projection. You want to output your data in a certain coordinate system. So you can input that parameter once and it can be shared among many tools. The other way you can string them together is using Python. And I'll talk about when you might want to use one versus the other, but Python allows you a little bit more control over your scripting. And in this demonstration today, I'll show you each individual tool so you know which ones that are used in this workflow, because really the goal of this is to show you all the tools that you need to use or that you can use to create this content directly from the survey data. They can all be strung together. You could automate the entire workflow that I'll be presenting today, but there are some points where it might make sense to stop and do a little quality control or QC after a certain step. I've broken this down into 3 phases, but these phases are really just conceptual phases. So now we'll step through each of these tools, and I'll show them to you here, and we'll talk about them, but then I'll go into ArcGIS Pro and I'll step into each of the tools, and we'll talk about the inputs and the outputs of these tools there as well. So these first couple of tools that you use are if your input is point data like XYZ. And I'm starting with XYZ just because that does require the most tools. So it's, I guess, the most complex workflow. But if you could also use bags, or you could use raster like GeoTIFF if you want to. Just so long as you have some 3D data, you can use it to generate these features. And I'll talk about where you would start in the workflow if you are starting with a GeoTIFF or a bag or something like that, something other than, say, an XYZ data set. So the first tool is this point file information tool. And this, for me, the data set I used was an XYZ file that I downloaded from the NOAA website. So I didn't know all of this information about this data set. sometimes data, and I believe some of the NOAA XYZ data sets do come with metadata, like an XML of the metadata. This is where you might be able to use some Python to pull that metadata, out of the file, and then you can use that to populate some of the information or parameters that are in the tools I'm going to show you. But since I didn't know that information, I needed to get this information out of the XYZ data set so that I could pass it to other tools in the workflow. And this tool gives you information like the name of the file, but really what's important for us for our workflow is the point spacing. So on average, how far apart are the points in this data set? And it also tells us if it's a positive down or positive up data set. So in this case, it's positive up, negative down data set. That's also used in some of the tools later in the workflow. The second tool we'll be using in this workflow is because we're starting with a XYZ data set, I want to convert it to a point feature class. So the tool I use is the ASCII to 3D to feature class tool. And if these are the first two tools, you really don't need these tools if you're starting with raster. So this is only because we have a point data set. But this gives us all of that ASCII data as a multi-point or single point feature class. Ultimately, we need a single point feature class because we're going to map some of these points to the soundings feature class in ArcGIS Pro. And then the next step in the workflow is creating a 10. So in our case, we're creating the 10 from this point data set, this multi-point feature class. But if you have a raster data set as input, you would use the raster to 10 tool. And that'll take multiple types of raster and generate a 10 from it. 10s are good because if you do have irregularly spaced points, it persists the original point location, so it's not a gridded data set. And for those that aren't familiar, 10 is a triangulated irregular network. So it triangulates all of the points. But what you can see here is that it doesn't necessarily know where not to triangulate. You can see that we got some data in this 10 that isn't really in the point data set. So because of that, the next tool we'll use is called delineate 10 data area. And this is where the average point spacing really is important, because one of the inputs to this tool is what is the segment length where I should cut it off so that I'm not triangulating across these points here. So you define that length, and that gives you more of the true shape of your survey. So this is an optional step that you can do. Maybe if you're making bathymetric ENCs and you don't necessarily care about the cartography so much, but there is an option to do this smoothing using a tool called Smooth Bathymetric 10. And here you can see an image of what the raw contours look like. So they actually don't look bad at all. This is 2 meter contour spacing. And I did 2 meters just because that was just easiest to see in the demo on screen. You can do decimeter contours if you wanted to. Of course, there's no limit on how dense the contours can be. But you can see these contours look okay, really. They didn't necessarily need smoothing. But if you wanted to do some smoothing on it, you can see here that this Smooth Bathymetric 10 tool, which takes the 10 as the input, so it's smoothing the 10, not the contours. You smooth that surface, and then you generate the contours from that surface. And this is good because it will prevent things like self-overlapping or intersecting contours, because you're not trying to smooth the line itself. And this tool guarantees a shallow bias in its smoothing. And then here I just did an image where you could see the difference between the smoothed in blue and the raw contours in red. So again, this is optional. You don't have to do the smoothing, but if you want to, this is where you would do it in the workflow. You do it before you make the contours. And this tool is in the bathymetric tool set, and I'll show you where you can find that tool. Even though I won't be using it in today's workflow, I'll show you where you can find that tool in case you want to do smoothing. So the second phase of this workflow is now that we have our tin, we're going to use the surface contour tool from the 3D Analyst toolbox to generate our contours. Again, I generated 2 meter spacing just because it showed up best on the image. And then we're going to capture the extent of the survey. And this is done using another tool from the 3D Analyst toolbox called tin domain. And it extracts the shape of the delineated tin. So in phase 1, when we created the tin, and then we used that delineate tool to capture the shape, you just are extracting a polygon of that shape. We'll use this later for some of the metadata polygons, so like the coverage area polygon that goes into an ENC. And then the next tool in the workflow is a new tool in ArcGIS Pro 2.9, which was just released last week, called Generate Depth Areas. So this tool uses the tin and the contours as input, and it generates a set of IHO S-57 or S-101 compliant depth areas. So they have the DR val 1 and DR val 2 populated. The reason we use the tin as part of the input is because if you have isolated contours, so you have an area where there's not, a lot of these areas, it's hard to see here in the picture, but you'll have, a contour on each side. So it's easy to figure out what dir val 1 and dir val 2 should be. But some cases you'll have an isolated contour where it's just a contour that's a circle. So you don't know if it's going up or going down in depth. And that's what we use the tin for. The tin can tell us if the area inside that isolated contour is shoaling or deepening. And then the last tool we use in this phase is called reduce point density. And this does essentially a sounding selection. Now, there are a lot of different options in this tool, and I'll show you those options when we get into Pro. But for the purpose of this workflow, I really did a simple sounding selection. I just did 100 meter spacing. Again, a lot of that is just for what visually it's going to be, you can see on the screen. But there are options in this tool to do ranges of sounding selection, so you can keep more soundings in shoaler areas and have fewer soundings in deeper areas if you want to. And you can also do a shallow and a deep bias sounding selection. So if you're probably going to want to keep more shallow soundings, but then later you also might want to do a pass and keep some of the deeps. And then phase 3, the last phase, is just creating the actual electronic chart, ENC, BENC, S101 data set. So there are some workspace XMLs, and a workspace XML, if you're not familiar, is really just a sort of predefined database template. So the Maritime extension in Pro comes with multiple database templates or workspace XMLs for S101 and for all the S57 data set types. So once you create that, you use import workspace XML, which is also a geoprocessing tool, to create that schema. Then you start appending these features, because all of the features we've been creating, the contours we created, the soundings we selected, the tin domain we created, they're all just in a scratch workspace. So it's just a sort of a throwaway workspace. We'll use the Append Geoprocessing tool to take the contours and add them to the depths L feature class in the Maritime Geodatabase. We'll take the soundings and append those to the soundings P feature class in the Maritime Geodatabase. And then we'll take the tin domain and append it to the metadata A feature class in the Maritime Geodatabase. And also, there are some tables in the Maritime Geodatabase that sort of define what the cell extent is and other cell metadata, and that's called the product coverage table. So you can put the TIN domain, that same TIN domain polygon would go in there. And then the last step is using the geoprocessing tool called Export Geodatabase to S57. This is in the Maritime toolbox. And that takes, all this data that I had put into a Maritime database in ArcGIS Pro here, and it exports it to S57. And I'll show this data set in ArcGIS Server as well in a web application. So with that, I think I'm ready to go into Pro and show you all of these tools, and we'll step through that workflow. Also, we have a poll question asking folks, we were kind of interested in, what type of bathymetric data you're using for your inputs. So you'll see the poll has opened, and you can see some of the choices there. Generically put raster, which could be any gridded data set there. And Kelly, I'm not seeing the poll myself, so maybe you can.
Yeah, it looks like we have just over half of everyone has put their answers in, so we'll just leave it open maybe for about 10 more seconds, get those last minute ones in, and then I'll share the results on the screen.
Awesome, thank you.
Mm-hmm. Okay, I'm going to go ahead and close this out, Craig, and we will share those results. It looks like about 45% of our attendees today chose XYZ. About, let's see, 19% chose BAG, 17% raster, 11% LiDAR, and then 8% use other. Okay, great. Yeah, so as I mentioned earlier in the demonstration or in the PowerPoint slides, you can really use any of these formats and many other formats as well. I just started with XYZ because it is quite common, but it's good to hear that, well, it's still common, let's just say that. And so I figured that that would be the best one to focus on, and also it requires the most steps, so great. So Kelly, can you tell me, can you see Pro now, or do I need to Yes,
share?
we can.
Okay, great. Okay, so what we're looking at here is, this is actually, I already converted the XYZ data set to points, and I'm just rendering it in this fashion because it's sort of easier to see the variant in the depths this way, but this really is a point data set, not a I know it looks like a raster data set here, but it's just because of how it's rendered. As I mentioned, all of the tools here that we're using in this workflow are geoprocessing tools, and there are lots of geoprocessing tools. We're going to be using a lot of the 3D analyst tools, but as you can see, there are tool sets and tool sets within tool sets. So there's lots of tools, and sometimes it can be sort of hard to find the tool that you're looking for. So you can add them as favorites. And the best way to probably find them is just by doing a search. So the first tool in our workflow is the point file information tool. So if you just start typing the name of the tool, and I've given you all the tool names in this presentation, then you can find them that way and add them to your favorites if you want. So the input here was the actual XYZ data set itself. So if you have an XYZ data set and you're starting with XYZ data, as 45% of you are, then you just browse to that XYZ data set here. And you can import multiple as well if you want to point to a folder. And then you're going to have an output feature class. So this is just asking you to name the feature class. it will automatically just write to your Scratch workspace, which gets created when you create your project in Pro. And then you're gonna, for format, you would pick the ASCII file with XYZ if you're starting with an XYZ data set. But as you can see, you can use multiple types of point data there. And then your coordinate system. So you do need to know the coordinate system. In this one, we're in UTM zone 10 north. So that might come in with some XYZ data. Maybe it comes with an XML or a TXT file of the metadata. And this is where in Model Builder, I could set this once if I'm going to build a model, and I would just connect this parameter to the other tools that use that parameter, which you'll see in the subsequent tools. And it can inherit it that way. You know, with Python, you could, if you had it in a TXT or in an XML, you could extract that information and pass it to this parameter. So that's one way in which you might want to use Python versus using Model Builder. And sometimes for me, I'll build something in Model Builder, and then I'll give it to one of the Python people on our team, and they'll make a Python script tool out of it. And I'm just kind of building, because even me as a product manager, it's Model Builder is easy enough that I can drag tools in there and connect them to one another. And then this is just if you have comma as the decimal separator versus point. So this data has point as a separator, but if you're in Europe, you might have comma as a separator. And then when you run this tool, it creates this data set here, or sorry, it creates this polygon. So it's really just a generic polygon. And if we open the attribute table, you can see there's that information that I talked about. It gives you the number of points. This has 100,000 points in it. The point spacing, the average point spacing, which is a value we will use in subsequent tools. And then this tells me the Z max and the Z min, which I will also use in other tools. And then it informs me if it's positive up or positive down, which I can essentially see from the data here. But all we're using the output of this for is this information. We don't care about the polygon or anything else. This is really throwaway. I just need this information. And then once I have that, I would use the ASCII to 3D feature class. And this is where I'm going to actually create the point feature class. So again, my input is the XYZ file here. So the input to the previous tool was the XYZ file. The input to this is also the XYZ file. Our format is XYZ. Then you're just going to, again, it's just a Scratch output feature class. We will use that Scratch output feature class later to do a sounding selection. And then we'll take that and put it into our Maritime database. But for now, it's just a Scratch feature class. Again, you can do multi-point or just single point features. That's later in the workflow. We do need it to be single point to put it in our soundings P feature class. I did make it multi-point in this case, especially if you have this isn't a very large data set really, but if you have very large data sets, there are lots and lots of points, it's easier to work with the multi-point feature class. And then later when you need to do your sounding selection, you could convert it to single point for that. Here's that shared parameter coordinate system that's used in a lot of tools in this workflow. So you really just want to define it once and then pass it to all the tools in the workflow. This is the parameter for the average point spacing. So we get that from the point file, the output of the point file information tool. So we have that 12 point something something for the point spacing. And then again, decimal separator. So another shared parameter. And that is what creates this point. And again, I know it looks like a raster, but it's really a point data set here. So once we've created this point data set, we're ready to create our tin. So again, this is in the 3D Analyst tool set, and it's just a create tin tool. So we're going to give a name to a tin. Again, this is somewhat of a throwaway thing, but we're going to generate a tin here. Here's that coordinate system parameter again, so you can see why you just want to input it once in Model Builder and pass it to all these tools so you don't have to keep setting it. Or again, doing that through Python. Our input feature class is going to be the points that we created, that multi-point feature class. That's the input to this tool. And then you run this tool and it's going to create for you a 10, right? So here we have that 10 that we've created. And again, as you can see, it doesn't quite match the point data set. Turn this off too. But because it's triangulated in areas where there's actually no data. So the next tool you'll need to use, now if you're using a gridded raster data set, you likely don't need to use this next tool either. But if in this case, because we have points where it wasn't a perfect rectangle, we need to define that shape more clearly. So we're going to take our input 10 and then we run the delineate tool on it. And this is where, if you remember from the point file information, we had that average point spacing. But you need to buffer that a little bit because the average point spacing, if it's in a regularly spaced set of points, is not going to represent sort of the maximum space you might want to allow. So this is where you may have to you can buffer it a little bit. And so a mathematical equation we found that works well if you want to automate this is 2 times the square root of the average point spacing. But this is one of those places in the workflow where after you run this tool and we end up with this delineated 10, you might want to QC this against the point data to make sure that it's accurately captured the extent of your data. So in terms of automatically calculating this extent, or doing the entire workflow end to end, maybe this is a point where you'd want to do some QC and say, yes, this is good. And now let's move to the next portion of the workflow and automate that piece. But if you have raster data, you don't need to use this tool if you have a gridded data set. So once we've delineated the 10, we could smooth the surface, right? So again, I said I'd mention where this tool was. There's called Smooth Bathymetric 10. So if we wanted to smooth this to have more cartographically pleasing contours, you would take your delineated 10 and it'll generate a new 10. So it doesn't modify the existing 10, it generates a new 10. You need to tell it the depth direction. In our case, our data was positive up and negative down, so the default is fine. And then the number of times you want to run the smoothing algorithm on the surface. And that will smooth it for you, and then you would go to the contours step. So if you don't want to smooth it, you can skip this. If you want to smooth it, you do this, and then we go to the next step in the workflow, which is surface contour. So this is in the 3D Analyst tool set. And our input surface is our delineated 10. And it'll generate an output line, polyline, a line feature class. And then you say a contour interval. So it could be, 0.5 if you want it to be 0.5. Or it could be, in my case, I chose 2 meter interval. And then you can have some precision. So maybe you want, if you're going to have decimeter contours, you're going to have to add some contour field precision. I didn't need to do that because I did 2 meter precision, so it's a whole value, so I didn't need to add any precision here. But if you do, you might need to make this so maybe 0.1 or something if you wanted to do decimeter contours. And then you would put the contour interval at 0.1 here, right? And then when you run this, it gives you a set of surface contours, which you can see here, which I've made this obnoxious color so that it shows up really well on the screen. But again, as you can see, these, sorry, I have a reference scale set here, so they're kind of thick at this zoom, but they're not bad, these contours. I wouldn't probably have smoothed these regardless. But so once we have our contours, we can also do the 10 domain here. And this could come really at any point in the workflow. We could have done this earlier, but this is where I did it in the workflow. So this is what's going to create the polygon output. So you're taking your delineated 10, right, as the input. It'll create this scratch polygon feature class, and you want to choose polygon here. You want to create a polygon, not a line. And once you do that, you'll get this, let me turn the contours off. You'll get this just shape, this polygon shape. And again, that we'll use in the metadata feature class, and also to define the sort of the product extent in the product coverage table in the Maritime database. And then we're ready to generate, now that we have, now that we have our contours and we have our delineated 10 that you can sort of see underneath there, we are ready to generate the depth areas. And this tool is in the Maritime toolbox. So again, we're going to input a 10. If you did a smoothed 10 and smoothed contours, just make sure you choose those two things together, right? So we have our delineated 10, we want to use that. We have our surface contour features, we want to use that. We're going to be writing, this writes directly to a Maritime workspace. And so these would auto-populate. So if I choose my target workspace to be this Bathy database, it knows where to pull this from and add these two. So it's going to write it to the depths area feature class in our Maritime database, so it knows where to write it to. I mentioned earlier that there's some things that come out of the point file information tool, which is the min and max Z values. So you need to define those here, but you could script this because you already know what your intervals are according to your own specification or the scales of charts you're creating. But if you recall from the point file information tool, the min and the max depth are always going to be some odd number that doesn't, conform to what your depth ranges are. So in our case, one of the just open this so we can write it's 72 is the shoalest depth and 159.9 is the deepest. But that's probably not what you want to set your depth range values to. So maybe the next value for a depth range for you, according to your spec or the scale of charts you're creating, is 60. So you'd want to put 60 here. And maybe the next deepest depth range, according to the data you're creating, should be 180 or 200. You'd want to put that maximum depth there. That way, if there isn't a bounding contour and you have, I don't know if there we go. If you have an isolated contour like this and it's searching, it finds that it's deeper, let's say. No, it's not shoaling, it's deepening. And if this was deeper, if your depth value range was deeper than 159, it would pull the value from here. So it's say, what should that value be for that depth area? So you define those two, which are probably not going to be exactly what you got out of the point file information tool. I hope that made sense. And then you're going to create your, let's turn these off so we can see this. You're going to generate your depth areas, right? So that's using the 10, the delineated 10, and the contours that were created from the delineated 10. Or if you had smoothed the surface, it's the smoothed 10 and the contours created from the smooth surface. And this gives you depth areas with Derval 1 and Derval 2. So you can see all the attributes in the data here, most of them null. There's a scale, so this chart is created at 1,000 or 2,500 scale. And here you can see all the depth range 1 and depth range 2 values. And that the subtype is the depth area subtype, or that's the S57 object type. So now that I've generated my depth areas, I can do a sounding selection. So for the sounding selection, this comes from the bathymetry tool set, and it's called reduce point density. And so we're going to take our input set of points that in its original density as the input. It'll write an output feature class. Again, this is Scratch. It'll later go into our Maritime database. You'll have to choose the depth field from this, which in my case is the Z field, but it's you choose the depth field, and whether it's positive up or positive down, and remember ours is positive up, negative down. We're going to do a shallow bias thinning, but again, you could later do and you could iterate this tool and do a shallow bias pass and with different start and end thinning radiuses and different start and end depths, and then you could iterate it and do a deep bias pass with different values here. But the start, this is really the only required parameter. So for me, I did 100-meter spacing, right? But you might want to do, and I just did it across the board. I did not do a start and end depth. So you really only have to fill out this parameter. In my case, again, I did 100 meters. But you might want to do a pass at 100 meters between a depth of 80, and 200 or something. And then you might want to do a different pass, a different radius with a different start and end depth. So you can kind of run it through multiple times and get different outputs and put that all together in the end, so that you have a range of densities of soundings. Now, once we've done a sounding selection, in this case, again, it's kind of a, I just did a generic one, so it's evenly spaced, 100 meters apart set of soundings. And if you have really high density contours, you probably don't need like decimeter contours, then you may not need soundings at all. So once we've done this, we're gonna use the Append Geoprocessing tool. So we have everything we need now, right? We have our sounding selection, we have our depth areas, we have our 10 domain, we have our contours. We now need to get all of that into a Maritime database. And you create a Maritime database simply by just right-click and create new file geodatabase, and it'll generate an empty can, essentially an empty database for you. And then you right-click on that database and you choose Import XML Workspace Document. Maritime comes with a set of pre-built workspace XMLs that contain schemas for the standards I mentioned earlier. So S57 ENC, Inland ENC, Bathymetric ENC, and S-101. And you can write to any of those. So you'll need to create that bucket, import that workspace XML. In this case, since I'm doing a bathymetric ENC, there's not very many S57 objects that are contained. It's a very trimmed down spec. And it does also allow you to set the ranges. So you can set the ranges from scale band 4, the usage bands, all the way to 9. So you have control over that in the, that's actually in the product coverage and product definitions table, which holds some of the metadata about these products. So this is where you'll be appending features, these Scratch workspace features into these feature classes. And to do that, we use the Append tool, which is in the data management tool set. So you just pick the input data sets and the target database, which will be that bathymetric, or in my case, it's a bathymetric ENC database that I created, which will point to that feature class there. And this is where you might want to, this is a tool you probably would want to script, because you're going to have consistent outputs that you know you're inputting into a consistent workspace. So this is really just taking all these different feature classes and then mapping them into our target databases. And then the last thing you need to do once you have all that, so I've done these, the Append tools, and here I have, you know, everything in that bathymetric ENC database. So I have, you know, the metadata. I copied the TIN domain into the metadata feature class. I copied the contours into the depth cell feature class, and I copied, or appended, I should use the word append. I appended the soundings into the soundings P feature class. Once you've done all the appending, you then use the export Geodatabase to S57 tool. There we go. Our source database is that BENC database, and I only have one product in here. So you'll get a list of all the products. That comes out of the product coverage table. So you pick the product you want to export. You choose the export type. If it's a bathymetric ENC, it's a new bathymetric data every time, so it's going to be new additions. And an output location, like where do I want to write this S57 file to? If you're using S-101, there's a tool called Export Geodatabase to S-101. Let me find that real quick just so we get the exact right tool name. So this is the location where it's going to write the 000 file. There's also some optional parameters that you don't have to choose. For example, if you have a full, maybe you have a full ENC schema with all the S57 objects, but you only want to export the bathymetric content from that full set of S57 data. There's a concept of a configuration file. This controls the mapping between the geodatabase and the S57 or S-101 data sets. So if you modify, you can make a copy. By default, it just does the whole spec. So if it's a Bathy ENC database, it knows which features need to go out. If it's a S57 ENC schema, it knows which features need to go out, so it just does the whole thing. But maybe you just want to do a subset. You can modify the configuration file that comes with the product to only map out certain features, and then you would point to that configuration file in that case. And then once you export, you get an S57 data set. And now I'm gonna, the next part of the presentation here, which I'll go ahead and step through a couple quick slides, and then I'll show you how you can visualize that data in web applications. So how you're going to do that is using what's called ArcGIS Maritime Server, which is an extension to ArcGIS Server. And this allows you to publish S57 or encrypted S63 datasets as WMS, REST, WMTS, so map services, essentially. It comes with a sample web application that gives you ECDIS or electronic chart display-like controls. It is not an ECDIS, but it gives you controls over things like whether it's in day or dusk, and you can turn certain themes and groups off, and things like that. It also has another application, which I won't be going into today, called Custom Chart Builder, that allows you to generate hard copy PDFs directly from this web service. So what is the Maritime Chart Service? It's really, you're just taking those S57 or S63 data sets and you put them in a folder, and what the Maritime Chart Service does, which is an extension to ArcGIS Server, what the Maritime Chart Service does is generates what's called a sync file, so our own custom syncs that can be rendered through ArcGIS Server and published as REST, again, WMS and WMTS services. And those can be used in web applications, in mobile devices, in a variety of different ways. One of those ways is using ArcGIS field maps. So this is just some screen captures of taking this ArcGIS field maps application and consuming this maritime chart service, is what we call it, inside of that application. So you can do things like data collection there. So you could take this out in the field and have people do data collection or corrections with this application. It can be pulled into a portable pilot unit or other types of applications as well. This is, and see, credit to the Royal Malaysian Navy's National Hydrographic Center here. They really came up with this slide. They gave a presentation on how they use the Maritime Chart Service and the different industries that they're using it in. And you can see this list here. Of course, it's really just data dissemination. So it's, instead of just keeping your S57 data where it's in an ECDIS or in your office, essentially, it allows you to distribute that information with certain groups of users. So you can control which groups of users have access to this data. It doesn't have to be provided for free to everyone, although certain agencies like NOAA do that very thing. You can lock it down to specific groups who maybe pay for access to that information. And here's a list of logos or customers that use this. So it is a widely used application. So now I'm going to get into a demonstration here of the Maritime Chart Service and showing you this data inside of a web application. This demo that I'm going to show you is accessible to everyone. You don't have to have an ArcGIS account or anything like that to go here. I will say that if you have visited this in the past, you need to either open this application again in an incognito window or clear your cache, because it'll cache the application and then you won't see some of the things I'm going to show. So if you visited the Maritime Chart Service application before, clear your cache or open it in an incognito window like I've done here, or you won't see some of these links I'll be sharing. So this is our own setup of our Maritime Chart Service application using ArcGIS Server and ArcGIS Maritime Server. We're using NOAA data in this application. You'll see this little splash screen pop up. Just click OK on that and click on this button here, and you'll see a list of bookmarks. If you don't see the bathymetric IENC bookmark, then you need to clear your cache or open in an incognito window. So we're going to zoom to that bookmark, and here you can see the extent of my bathymetric ENC that was created, along with all this other scale band. Well, this is all the scale bands really of NOAA data. So, but there's scale band 5 data in here as well. So we can go to our settings. You can see I can see the M covers just because it's set to true to show all the M covers. But if you want to see the bathymetric ENC data here, you have to turn on this display bathymetric inland ENC setting. And now you can see my bathymetric ENC. And one of the things this does, this setting does, with this particular type of data, because it's a special type of S57 data, is that it sort of interleaves the this inland bathymetric inland ENC data with the S57 ENC or inland ENC data sets in the application. So it knows not to, so there are no wrecks or obstructions or anything in our bathymetric ENC, but you can see one there. So this data set isn't simply drawing right on top of the scale band 5 data, it's interleaving itself with it and only replacing or sort of virtually cutting out the features that it has. So the contours, the soundings, and the depth areas. And we can see that here if we do an identify in this location and we get the certain features in this extent that are from the bathymetric ENC, but then you'll also see there's no magvar in our bathymetric ENC. It's coming from US 5 Washington 15M. So it knows which features to identify from which of the data sets. So it's really drawing both, except using bathymetric content only from the bathymetric ENC. And if you set, there's also safety contour settings here. So if you set the safety contour to something like, let's go 80. You can see it uses the safety, it uses it from here and also from our, it sets it in the bathymetric ENC, but also it sets it in the ENC, in the scale band 5 ENC. So something else we can do with this is we can add content to it as well. So if I want to add the latest, if I want to add sort of the latest bathymetric data, I can add that here and then go to my layer list and move my ENC up to the top. But then I can set a transparency on this if I want to and start to see the bathymetric content underneath it. Maybe I actually just want to, I don't even want to use the land information from the scale band 5 ENC. I can just turn it off, and then I could have, maybe a different, if you have your own, when you click to add a base map, in case you have your own base maps, it'll ask you to log in, but you don't have to log in. You can just click cancel there. And these are all the openly available base maps through ArcGIS Online. So I can add my own custom base map as well, turning off the ENC content from the scale band 5 data. So here you can see how you can take this data all the way from XYZ, create bathymetric ENCs or updated S57 ENC, inland ENC or S-101 data sets. You can automate that workflow to whatever degree you're comfortable with, because all of the tools that we used here are geoprocessing tools, so they can be strung together. And then not only that, but once you're done and you've generated that ENC or S57 or S-101 data, you can publish that as REST services, WMS, WMTS, and it can be consumed in a desktop web application like this one, or in a mobile device or PPU, portable pilot unit, things like that. And again, as I mentioned, this is the link to this Esri hydrographic office account. What I demonstrated today was this Maritime chart service application, but there are many other applications here that show sharing bathymetric data, that have the, as I mentioned, there's that other capability that allows you to generate PDFs directly from this Maritime chart service data. So there's applications for all of these things there as well that are open to everyone and accessible. So you can go here and generate your own chart PDFs, or just go play with this Maritime chart service data that has NOAA data, and also our bathymetric ENC is up there for everyone to see as well. That concludes our presentation for today. Here are some helpful links for you, though. We have this is that website I was just showing you with all the apps that are available. We also have a community page. So this is where we blog here, and there are links to product pages and other types of information about maritime videos and things like that you can get to from this community page. And then you can contact us directly as well at maritime@esri.com. And with that, I think we'll look and see if there's any questions. Looks like I see a question about, are the contours smooth on the safe side? Yes. So if you use the bathymetric tool, the smooth bathymetric 10 tool, that smooths the surface in a shallow biased way, and then the contours are generated from that smooth surface. So the surface itself is what's being smoothed in the safe fashion. Let's see here. Let me see if I can get a better look at the questions. I don't know, maybe Kelly, can you help with, do you mind reading some of the questions?
No problem. And we have quite a few here, so we'll get through as many as possible, and then we can always respond individually as well after the webinar. So the next question I see is, are you able to set your own rounding rules?
Are you able to set your own rounding rules? Yes. So when that's just math. I guess you do that in Python. So that's something you could do with Python. So if you wanted to, by default, when you export from our database, it uses the S57 rules or S-101 if you're doing S-101 data. So it doesn't matter what precision you store in the database. You can store lots of precision. When we export, it will be truncated to S57. There is configuration, so you do have control over what that is. But if you want to do something like S4 rounding rules, so the paper chart rounding rules, where you're maybe cutting off at 30 meters and you're not showing any decimeter values at all, you could do that with Python.
Okay, great. Thank you. Next question I see here, NOAA uses some custom S57 attributes in addition to the standard S57 attribute catalog. Can those attributes be added to the Maritime GDB template?
Yes. And in fact, if you add them to the mapping file that maps attributes in and out of the database, it will map them in and out between S57 and the database as well. They wouldn't be necessarily valid S57 attributes, but whatever you put in the mapping file and whatever you put in the database will go out. So if you don't want it to go, if you want to keep it in your database, but you don't want it to go out to S57, you just add the fields to your database. They'll never go out to S57 because they're not in the mapping file.
Got it. Thank you, Craig. Next question here. I prefer using BAG instead of XYZ. Do you have any solutions as an alternative workflow?
Yeah, use the raster to tin tool. So you wouldn't need to use the ASCII to 3D feature class point file information. You wouldn't need to use those tools. You wouldn't need to delineate the tin, but you'd use raster to tin, and the BAG would be your input and the tin is your output, and from there it's the same workflow.
Okay, great. Thank you. Next question. Is it possible to select other separators than point and comma in the point file information tool? For example, a semicolon.
Not that I'm aware of. I might have to follow up on that one. You'd probably have to do, again, maybe some Python there.
Okay, and next question, I believe from the same person, so it might be a follow-up. If I use an XYZ file, how is the column separator defined? Is the column separator determined automatically?
Yes, it's just determined automatically.
Okay, got it.
Mm-hmm.
Okay, and next question, can you do a non-standard contour interval? So for example, 0, 2, 5, 10, 20, 50.
Yeah, so we did do that. We did it with a Python script. So if we wanted, if it was 0, 2, so the most fine interval we wanted, and then we used a Python script to go in and remove the ones we didn't want. So yes and no. Your first output would be, so in that case, if it's 0, 2, it would be 2 meters. And then you'd have your script go in and clean out the ones you don't want. So you're talking more about the sort of standard S57 or even S4 contour intervals. How we got around that was just using Python to delete the ones we didn't want. So it's automated essentially. You attach the Python to the tool, you generate the contours and then it just automatically deletes the ones you don't want.
Got it. Thank you so much. And we're going to go ahead and do one more question. I know we're at the top of the hour here, so we'll make this the last one. I know there's a lot of questions in the box here, so we will be replying to those individually later on after this webinar. So our last question today, how do you integrate the new data with the existing data on the cell?
Yeah, that's another really good question. And that can be done with additional tools. I don't know if all of that, we did do a bunch of documentation in the latest version of Pro, but if you contact me directly, I do have a document on how you do that. Essentially, and I don't want to get the names of the tools wrong and lead you in the, but what happens is you cut out the old, you use that same 10 domain, that shape that we created, that polygon, and you cut out the old data and paste in the new. But there's a trick to getting edge matching, which I can share sort of on the side in that document for anyone that's interested. Just reach out to our contact here, and it's all automated as well. It's all geoprocessing tools if you want to do that. So yeah, that is supported.
Okay, great. Thank you, Craig. And again, I know we have a lot of other questions here, so we will be replying to those individually. And again, Craig, I'd like to thank you for the presentation and demos today. That was very informative and very helpful. And just so everyone is aware, we have recorded this webinar in its entirety. We will be posting the recording location so everyone can watch at their convenience, share with their colleagues, and also have another opportunity to ask any questions on that community page that Craig has the link to on the slide. So any links you see today, we will be posting and sending out an email probably within the next day or two. And with that, I think we will go ahead and close this out. There is a survey at the end, so as soon as this closes, if you wouldn't mind taking a minute and filling out our survey on the webinar so we can bring you better topics for next year, for 2022, and make sure we address everyone's concerns. So Craig, unless you have any final thoughts, I think we will go ahead and close this out.
No, thanks everyone for attending.
All right, thank you. Have a great rest of your day, everyone.